And I want to introduce this guy that's coming up. His name is Richard Boyd. Richard is also a DevOps Days organizer, but for DevOps Days Austin. He is a senior technical account manager at AWS. So let's welcome to the stage Richard Boyd.
All right, can everybody hear me? Great, mic's working, perfect. Good morning, Dallas. How are you guys doing? Awesome. You feeling DevOpsy today? All right, we're gonna get into it. So this talk, title up there, how to step up your DevOps with step functions. Recently, over the past 2 years, I've been playing around a lot with Lambda and Serverless, and it's kind of how I'm in front of you guys today. So if you're a developer, I hope you get some ideas out of this. If you're an operations guy, I hope you can relieve or alleviate toil after this talk. If you're a manager or security specialist, there's a lot in there for you too. So pay attention, and maybe we'll do a tech demo at the end. So my information, I'm Richard Boyd. I have been a TAM at AWS for 5 days now. I started Monday. Actually drove in last night. So you guys have lovely traffic here in Dallas. And then that's my Twitter handle and my website. So we're gonna go through 5 things today, right? I'm gonna start talking about how I solved a problem. Then we're gonna talk about serverless and step functions briefly. Then we'll dive into a pattern for reusable lambdas, go through kind of parsing together how step functions work, how you should think about those, and then do a quick demo. So this takes place over the past 2 years, and it involves a problem, and this is the problem. So one of our vendors, the company I worked at, had a large Microsoft SQL database. They would give us a database dump in the middle of the night. That database dump had to be turned into a Microsoft SQL database that we stored in AWS and had to be available for a data warehouse team to run some business critical reports off of. Now, this process had a lot of sharp edges. One, we never knew when we were going to get database backups, right? They could happen at 2 o'clock, 3 o'clock, 4 o'clock, 7 o'clock in the morning, 8 o'clock in the morning, 9 o'clock in the morning. Second, a lot of this stuff was kind of manual hand-holding. For instance, in Microsoft SQL for RDS, there's a stored procedure where you can go in and restore from a database dump in S3. That's a manual process. We're using Active Directory for user privileges in Microsoft SQL, so we had to go in and restore those privileges back over the restored database from the dump file. And then we had to let the EDW team know. And oh, by the way, they're in Minneapolis, and I'm in Austin, Texas, right? So in order to figure out how to automate this, I started looking at Lambdas, which I played a lot with, and then started looking more at step functions to try to use that as the glue to glue that process together. So this is what the solution ended up looking like. The vendor would copy that database dump over to an S3 bucket. That put event, the event of just putting the file in S3, would kick off this Rube Goldberg machine that would do all the rest for me, right? And so the database restore step function did everything from check if the database existed. It would then dump the database if it did. It would restore the database. It would then go through and restore the privileges from Active Directory, and it would send email notifications out to the EDW team so they knew exactly when each database was restored. Now, this is also scalable because if they added more database dump files to be processed, we could add in the logic in the invoking function, and then boom, that process is immediately expandable to however many databases they want to throw at us, right? So once that initial work was done, very little care and feeding. We had triggers in there for Slack notifications in case there was failure. And all in all, it was a really fun project to work on, which gave me ideas that I used in other areas of the company. Serverless is a fancy buzzword. Basically, it means your code runs in these short-lived execution environments. There are still servers, but you don't have to worry about them. And your code executes in response to events. That's the key part, right? Who here has heard of event-driven architecture? Yes, right? For those of you that don't, Event-driven architecture just means that something happens over here that kicks some dominoes in a Rube Goldberg machine that makes your thing happen over here, right? So instead of having some kind of like cron timer running every 5 minutes or every hour to process code, we're actually going to create and execute architectures in response to something happening in our infrastructure, which means that we don't necessarily have to have servers idle, wasting money waiting for an event, waiting for a cron timer to kick off. Instead, we can invoke infrastructure or invoke processes when things happen, right? So, Lambda dissection. Who here has played with Lambda before? Some of you? Decent amount. So on the back end, this is what I want you to come away with this part of the discussion. You control about this much of Lambda and about that much you don't, right? So in the back end, your code is running inside of an Amazon Linux container, right? That container is the full contents of the Lambda. The Lambda is then running on Amazon's spare compute capacity, right? So most of the stuff you don't control, very little of it you do control. One interesting thing that you should walk away from knowing is that even though you're running in an Amazon Linux container, your Lambdas can actually shell out and execute command line args. If you wanted to run Golang inside of Lambda, you actually had to pack up your binary, ship it in with a zip file with a Lambda, and then shell out to execute your Go before Amazon announced Golang support for Lambdas. But when you are running Lambdas, you are giving up a lot of control to Amazon. And so you need to make sure that you understand that when you write your code and that limitation is kind of built into the way you build things. Step functions is basically like gluing all this stuff together. So within step functions, you have tasks, you have states, and within that task-state dichotomy, you basically build a logical diagram. So what you have on the right is a sample of a step function, right? You can see that each one of those states, like submit job or wait X seconds, those are different states inside your step function. And as that step function executes through those states, it can call out to Lambdas to process things. In fact, within states and between states, you can have logic like wait retry loops. You can fan out to where you parallel process multiple things at once. So if you're an automationist and you're looking for ways to kind of like speed up your processes or take something that's manual and express it in automation, there's a lot there inside of step functions that you can use. Also keep in mind that with step functions, every time the step function executes, that's a different invocation, right? So even though we have this model of this process that we want to kick off, every time it kicks off, that's a brand new invocation of all of the events and all the Lambdas inside of that step function. That means that you can now audit each invocation if you're processing massive numbers of files. You can actually build in manual steps that will send emails out. So you can click on a button and then kick back into that execution and then finish up that invocation. So there's also a lot there that you can kind of bolt on functionality to. And there's a lot of stuff that people have done online. The Amazon Web Services documentation is really well written for these types of processes. So I want to talk about how I build Lambdas, because I think there's a lot of ways to do them, and I have recently kind of come to a kind of a fork in the road about how I want to think about them that I want to share with you guys. So who uses a serverless framework like SAM or Serverless or Spartan, right? So most serverless frameworks, when you are building something that has serverless built into it, whether that's a web service with API Gateway, DynamoDB, and Lambda, or if it's a single-use Lambda function, most of these serverless technologies and these application structures focus on creating this end-to-end thing, right? But if you start looking, like if you're a shop that does a lot of Lambda work and your developers are creating a lot of serverless automation or serverless tools or serverless microservices, what you'll start to see is there's a lot of wasted code. There's a lot of of work that developer one's doing that developer two is also doing. For instance, if you're handling S3 files, you can only do that a couple different ways, right? So there's a lot of code that's not built for code reuse, and a lot of it is actually built for, or a lot of it's duplicated as people are going through and building their applications. So as an operations guy, and that's where I'm coming to this from, as an operations guy, one of the things I've started trying to do is build my Lambdas like Unix, in kind of a very Unix model. And what I mean by that is, at the top of my Lambda functions, I'll always state the input and the output, right? Just like a standard Python function, right, when you're documenting your code, what do they accept and what do they give back to you? Because what you'll find is that if you're having to handle S3 files, instead of creating a S3 file Lambda for each application that you're building with your application framework like Serverless, you can actually just build one Lambda and then make that reusable or recomposable inside of a larger step function or inside of a larger architecture. And even if you're gluing together your Lambda invocations with SQS, you can probably slim down the number of Lambdas that you're running in production by focusing on building them for a single purpose or a single tool. Same thing when it comes to writing to CloudWatch logs, sending emails, Slack notifications, interacting with other services out there like Datadog or CircleCI or whatever. If you focus on building your Lambdas so that they can be reused, you slim down the amount of code that you have to audit, and you kind of make it easier for people to take these bits that are already on the shelf and then recompose those into different applications. So you're basically taking a microservices approach and you're applying this to your toolbox of Lambdas. All right, so the next thing I want to kind of jump to is step functions. Who here is actually working with step functions in production right now? All right, so this will be fairly new for some of you. So a step function is a finite state machine, right? All that means is that when we give this state machine data or an event, we know based on the logic inside of that state machine what it's going to do next, right? That's a knowable thing. It's not indeterminate, right? It's not a black box. It's a fairly robust data flow diagram, so we know how do we get from point A to B to C to D, or maybe to F, or maybe to Z, or maybe to X, based on the data that we pass through it and the logic we build into it, right? The big component of all this is this diagram right here. So a step function is just a business diagram that we are expressing with some code, right? So if there is a process that you have that is fairly linear or doesn't have too many logical branches, it is a prime candidate for automation. And step functions give you the ability to do those things. What you'll find as an operations person or a developer out there is that you have these kind of siloed events or siloed processes that have to happen. You know they happen a certain way. With step functions, you can actually start to glue those things together and do that in a way that actually brings your cost down instead of having to have a server that's running 24/7, 365, right? Because ultimately we don't want to waste money, we don't want to waste compute, we want to make sure that we're running as lean as possible, right? Within step functions, there are two portions to kind of talk about also. There are states and tasks, right? So, going back into the previous diagram, let's see if this will work. There we go. So going back into the previous diagram, each one of those blocks on the right side is a state in our step function, right? Those are where we actually execute logic. So if we want to send a Slack notification out, maybe we'll have a state for sending a Slack notification, right? If we want to have a state that fans out and processes two things in parallel, we can do that. Maybe we want to have a state that will actually run another Lambda and evaluate the return of that Lambda, and then use that as a decision point whether we go to the next block of our step function or we go back into a loop, right? So the other piece of that is tasks. So a task is a thing that you do inside of a state, right? So when you jump into a state, if a state is where you're going to be doing something or invoking a Lambda, right? That's where you execute those things as far as tasks. And there are two types of tasks inside of step functions, and I think this is where there's also a lot of capability or there's a lot of room for expansion there. So normally you think about running a task as just a Lambda, right? I'm going to fire a Lambda, I'm going to pass it some kind of event, and then the Lambda itself is going to go do something. There's also activities. Activities is actually a daemon that's running on your own infrastructure that's waiting for a job. So with Lambda, you got a 5-minute execution window. With activities, you could have something waiting on your infrastructure to take that job and be able to break out of that 5-minute window. So let's say there's like a large EMR process that you want to run, or there's some kind of like complex computation that you need to do on data files coming in. You could actually run that on your own infrastructure and still tie that into the step function execution and then break out of that 5-minute kind of box that Lambda gives you. So those are the two big components inside of a state machine. So the next part, we're going to see how this works. We're going to do a quick demo to kind of put things together. This is a very simple demo, but it kind of shows some of the things I've been talking about. So what we're going to do is we're going to glue together some step functions. We're going to use some lambdas inside the step function to process files that we're going to put into S3. We're going to invoke those files just by putting them, we're going to invoke the step function by just dumping the files into S3. And then we're going to write them out to DynamoDB, and we're also going to send an email to my email address, right? And then each one of those invocations, each one of those files will spawn a separate step function invocation, right? And then we'll be able to look at that as it kind of moves through the system. So this architecture is, okay, so this is my laptop. Let me get that. All right. So these files are very, very simple. Let me give you an idea of what we're going to be playing with here. So let's see if I can do this in a little bit. So very simple JSON file, album, genre type, artist, title, year. Some of them are movies, some of them are albums, some of them are books. So all we want to do is bring the file into S3. We want to strip out some data, and we use that data to kind of drive the rest of the step function. So we're going to grab our files and upload them real quick. Okay. All right, so we've got our 5 files. Just going to drop those over here, upload them. Oh, come on, Wi-Fi. All right. Let's try one at a time then. Great. All right, just bear with me, guys. While I'm trying to get my demo to actually respond, open up some quick questions from the audience. Oh, it's just on Wi-Fi too.
It's going to be curly, I think.
Horizon is Mo. Okay.
HBK 4 TSP.
Okay.
It works.
Let's try it. I'm still trying to connect to the puck. It's not working with the puck. All right, let's try this one more time. I'm going to try it back on the BYOD network real quick. Yeah, it would never connect to the... All right, well, that's depressing. All right. Okay, so there won't be a demo today, unfortunately. Yeah. Inside of Step Functions, the biggest thing I want to take away from, and demo guys were not kind, obviously, right? So, I know. The biggest thing that I want you guys to take away with Step Functions today is if there's a process that you're doing the same way every time, if it's a manual process, if it's full of toil, if it has a lot of steps to it, instead of going out and building some kind of Baroque automation that you have to care for, maintain, put duct tape around, and baling wire, instead take a look at Step Functions. Even if you're not using Amazon Web Services, you have the ability to write Lambdas that can call out to APIs and other services also, right? You're not just constrained by using service inside of AWS. As I've been using Step Functions, it's kind of really expanded my horizons when it comes to what kind of problems I can solve and what I can actually do with them, right? Just some ideas, right? There's as an example of something else that I've done, there is a thing called an Sftp Gateway. You can launch it in the Amazon Web Services Marketplace. It basically is a S3-backed Sftp server, right? So as soon as files hit the Sftp server, they're automatically swept to an S3 bucket. From there, that invokes a put event that you can then use to build out processes to copy the files over to, say, Dropbox or to an archive bucket, send email notifications for people that need to know those new files are coming in. And what you should be thinking about besides what you can automate inside of engineering land is how you can automate things for people that aren't engineers also, right? If you just walk outside of your cubicle and go talk to somebody in marketing or sales or HR, you're gonna find there's a lot of people that are dragging files from one screen to the other, and that's wasting time, right? That 5 minutes that they're spending doing that thing every single day is cutting into productivity and keeping them from doing their actual job or doing something cool with their job, right? So as as people that, in the calms of DevOps, right, the automation, as kind of ambassadors towards calms and ambassadors of automation, you can take this kind of stuff elsewhere and start helping other people in the company out. Because I guarantee you, outside of engineering, most people don't understand what automation is, and they don't understand what cloud is, right? And with step functions, the ability to kind of like do these, automate these logical business sequences that they're doing every single day, you can help everybody out in your company. All you gotta do is start asking, right? And then once you do something for somebody, once you start earning their trust, then they're gonna give you more work to do, and that'll allow you to automate your entire business, right? So that's kind of, for me, what gets me excited about step functions. For me, that's what this kind of serverless technology really brings to the table. It's not necessarily about processing video files or moving files from point A to point B. It's the ability to take manual processes that are killing people or making people just hate coming into work and automating that stuff away so they can start doing really fun stuff with their job, right? That's what gets me excited. That's what gets me going. So I really appreciate the time. I am sorry that the demo gods just were not happy about me being in Dallas. Do you guys have any quick questions before I get off the stage?
I do, real quick.
Go for it.
Step functions versus SWF. Do you have a preference for step functions most of the time? It seems like you gave a presentation on that.
Simple workflow, and even Amazon Glue does the same kind of thing, right, for ETL. For me, as an ops kind of person, I really move towards step functions because there's a lot of depth there, especially with creating logical gates and loops or fan-outs inside of the step function themselves. And then being able to go in and diagnose each one of the invocations, or at least have those invocations auditable. Putting my security hat on, if I've got a process that I need to show to an auditor for like SOC 2, I can immediately go and pull out all those invocations and then show them, right? I can even have a service, a step function that will go through it periodically and then pull all those invocations out, dump them to S3 as some kind of like log file capture that I can then show to them that, hey, this stuff is actually auditable. Because that'll be the one thing that's always gonna get in front of you is, how do I audit this thing, right? You're gonna automate this business process. How do I show it to the security folks that we can actually knowingly say, on this date, at this time, this file was handled, and we did this stuff to that file, right? So that's why I tend to go back to step functions. There's a lot of depth there.